This is the demo for Lesson 2 for College Algebra. So today we're going to talk about mathematical models, or more simply, models. A model is a mathematical representation, such as an equation or a formula, of a real-world situation. If we can describe the relationship between two or more quantities, we can write an equation relating them. We call that thing a model. This is an important step in problem solving, being able to convert a description of a relationship into an equation. So let's use some math to talk about the average tuition and fees from the preview exercises. So I've created a formula here that estimates the average tuition and fees. So it models the average tuition and fees T for the academic years since 85 to 86. So we're going to call this year 0. So 86 to 87 would be year 1, 87, 88 would be year 2, 2005 to 2006 would be year 20. So I want to use the formula to estimate average tuition and fees for year 20 years after 85 to 86. So, and then we can compare that to the actual. So I'm just going to plug in 20 for the x's in the model. So I'm going to have T for tuition is going to be 5.46 times 20 squared plus 66.98 times 20 plus 2,985.85. And I'm going to have a calculator do this for me. And I get 6,509.45. So if I want to write a sentence, I'm going to say the model, the model estimates that tuition was $6,509.45 in 05-06. And we can compare that to what the bar graph said in the preview exercises, which was 6,492. So this is a pretty good estimate for what the real data actually says. So by how much does the formula underestimate or overestimate the actual tuition? I subtract. So it's a slight overestimate. Overestimates by, I'm just going to subtract 6,509.45 minus the actual number of 6,492, and I get $17.45. Then I want to use the same model to predict average tuition and fees for 79 to 80. So that's before year 0. Remember we called 85, 86 year 0? So this is going to be 6 years before that. So I'm going to plug a -6 into my formula. So T is 5.46 times -6 squared plus 66.98 times -6 plus 2,985.85. And we get $2,780.53. Next, I want to use the model to predict average tuition and fees in 2019 to 2020. That is 33 years after 85, 86. So you just do a quick subtraction, like 2020 minus 1986. Oh, that's actually 34 years. 34 years. So I'm going to plug in 34 for x. So 5.46 times 34 squared plus 6698 times 34 plus 2,985.85. Okay, so that comes out to 11,575. Okay. So do those values seem plausible? I think so, yeah. But sometimes a model, if we extend it too far beyond the range of the data, can lead to estimates that don't make sense or are unreasonable. In that situation, we say that model breakdown has occurred. And that may be the case here because actual average tuition and fees for 2019-2020 was $10,281. So we're really starting to overestimate if we continue to use the model. Our next topic for this lesson is sets. A set is just a collection of objects. So for example, we could have the set of students in this classroom, the set of large species of cats, or the set of Oscar winners for Best Actress. The objects in a set are called the elements of the set. We can write a set by listing all of its elements between curly brackets, and this form of set representation is called the roster method. For example, we could let A represent the set of the Three Stooges, and the notation would be A equals Larry, Moe, and Curly between curly brackets. And we use commas to separate the elements. So another example would be the four Beatles. Okay, so the set of Beatles that arrive, I have to be specific here because the members changed prior to 1964, but from that point on, the Beatles are John Lennon, Paul McCartney, George Harrison, and Ringo Starr. So the sets we encounter in this class, though, will typically be sets of numbers. We'll use the following methods to represent sets of numbers: set builder notation, interval notation, and real number lines. So set builder notation is a descriptive way to write a set. Generally speaking, it takes this form. You have a curly bracket, and then an X, and then a vertical line that you would read as such that. And then X meets some conditions. So it would be the set of all X's such that whatever conditions you want to put on X. So for example, I could write the set of all X's such that X is greater than 2. And if I wanted to use a real number line to express that, I would put shade all the numbers bigger than 2. And to be clear that 2 is not included in the set because we're only talking about numbers bigger than 2, I use a round bracket right here. And then finally, in interval notation, I would use the same round bracket and I would write 2, infinity. So 2, you always do the smallest number in the set to the biggest number in the set for interval notation, separated by a comma. So 2 is the smallest, infinity is the biggest, but we don't include either number in the set. So 2 it's not the smallest. There is no smallest number in the set because you can get smaller and smaller and smaller without passing 2. But we put a round bracket on the 2 because it's not included. And we put a round bracket on the infinity because infinity is not a number. You can never get there, so you can't include it in the set. If you wanted to actually include the endpoint in the set, you use a square bracket. That indicates that an endpoint is included in the set. So if I want to represent each of these two sets using interval notation, we do the smallest number in the set, which for this first number line looks like it's -1, comma, the biggest number in the set, which is 4. And do I include the endpoints? Well, I have square brackets on those, so yes, square brackets on the interval. And then for this one, the smallest number in the set, there isn't one. It just keeps going left forever, so we're going to do -infinity. And then the biggest number in the set is a 1, but it has a square bracket on it, so I use a square bracket on interval, which means the 1 is included. And then you always put a round bracket on infinities.